Okay, so in this video, we will be discussing about the Napier's rule and finding the area of a spherical triangle. But first, let us have the Napier's rule. So in Napier's rule, we can only use this rule if our spherical triangle has a 90-degree angle. So let's see for an example. We have this triangle. So this is a 90-degree triangle. So this angle is angle C. The opposite side of angle C is side C. Then this is angle A. Then the opposite side is side A. Then this is angle B. Then the opposite side is side B. So take note that the capital letters of a spherical triangle represents the angles, and the small letters represents the sides of the spherical triangle. So in Napier's rule, we must be familiarized about the Napier's circle. So by memorizing it easily, we must do this technique. First, let us draw a man with the body, then the legs, then the two hands. Then make a big circle from that. Okay. So suppose we must put the C bar, the small letter C. Then the adjacent sides of the C bar is the A bar and the B bar. So in the upper portion, we must do the alternate. Since this is A, so we have to put this one as B. Then this is A. So that is the Napier's circle. Again, so let's do this, or let us draw again the Napier's circle. First, we have to draw a man with the body and the hands and the legs. So make a circle. Then suppose again C bar, the small letter C. Then at this time, what if na-interchange na to si A bar and si B bar? So for example, this is B bar and E bar. Okay lang siya. Ato lang is basta kay alternate ang dire sa upper portion. So since this is B bar, so it must be A and this is B. So that is the Napier's circle. So in Napier's rule, we have these two rules, the sin co rule and the sin tan ad rule. So first, let us have the sin co rule. So in sin co rule, it is stated that the sine of any middle part is equal to the product of the cosines of its opposite parts. So that is the sine is equal to the cosines of the opposites. So that is why it is called as sin co rule. So let us have an example. So for example, we have the sine A. So sine A. So since sine A is equal to the opposite of sine A is the A bar and C bar. So opposite of A is A bar and C bar. So, ato lang kuhaan na siya cosine ni A bar and C bar. Cos, then this is cos. So that is the sin co-op rule. Let us have another. For example, we have anita ni B bar. So sine B bar. So the opposite of B bar is A bar and B. So A bar and B. So the same, get the cosine, cos A bar and cos B. So that is for the sin co rule. For the sin tan add rule, so it is stated that the sine of any middle part is equal to the product of the tangent of its adjacent parts. So, nana siya, sine is equal to the tangent of the adjacent side. So that is called as sin tan add rule. So, for example, we have sine B. So sine B bar. So we have sine B bar. Okay. Sine B bar. So we have to get the adjacent of B bar. So the adjacent of B bar is the A and C bar. So A and C bar. So just get the tangent of A, tan A, then tan C bar. So that is the sine, cosine, opposite, or sorry. So the sine, tangent, adjacent rule, or what we call a sin tan add rule. Another. So we have sine B. So for example, sine B. So kindly get or find the adjacent of B. So the adjacent of B is A bar and A. So A bar and A. So tan and tan. So that is the sin tan add rule. So now let us have an example. Solve for the spherical triangle whose parts are A equals 73 degree, B equals 62 degree, and C equals 90 degree. So in this problem, we have the angle C is 90 degree. So therefore, we can use the Napier's rule. Then take note, the small letters represents the sides and the capital letters are the angles. So let us draw the spherical triangle. So this is 90 degree. So this is angle C. Then the opposite side of angle C is side C. Then this is angle A. Then the opposite side is side A, which is equal to 73 degrees. And this is angle B. Then the opposite side is side B, which is 62 degrees. So, to use the Napier's rule, we must be familiarize again the Napier's circle. So let us do the technique. So draw the man, the body, then the legs and the hands. Then make a circle. So again, sa ubos, we have to put C bar, the small letter C. Then the adjacent sides, either A bar or B bar. Then the upper portion, we must do the alternate. So since this is A, so we have to put this one as B, and this is A. So by the way, what if the A bar, C bar, and B bar are the complement. So example, this is A bar. So A bar is equal to 90 minus A. Then B bar is equal to 90 minus B. Then C bar is equal to 90 minus C. So, plus, kani siya, this is our answers. If we get the value of A bar, B bar, and C bar, so we must subtract it to 90 to get the answer of the angle A, B, and the C side. So, for example, let us have this problem. So, as what you have observed, the given is only B bar, the B side B and A. So this one. So in Napier's rule, we have two rules: the sin co rule and the sin tan rule. So at this time, we can find the value of C bar. Since we have the given is A and B, so these are the opposite of C bar. So we can use the sin co rule. So let us solve. So sine C bar is equal to the opposite. So the opposite is B and A. So that is cos, then cos. So that is sine C bar plus cos. The value of B is 62 degree. Then the value of A is cos 73 degree. Then we get the value of C bar. Simplify this one. C bar is equal to 7.89 degrees. So always remember, this is not yet the answer of C. So we have, since this is the complement, so ito pa na subtract. So it is C bar equals 90 minus C. So simplify. So the answer is 82.11 degrees. So that is the value of our C. Next is let us find the value of A. So since naanatay value ni C bar, we can use the sin tan add rule. So let us sin A bar is equal to, so A bar, the adjacent sides of A bar is B and C. So that is tan B and tan C bar. Just substitute. So B is equal to 62 degrees. So tan 62, then tan C bar. So at this time C bar, this is C bar, not yet the C. So we must put the value of C bar to 7.89 degrees. Okay, so then simplify. So sine A bar is equal to 15.1 degrees. Okay, since this is, so that is the value of our A bar. So since A bar na siya, paon na to ang value ni A. So it will become A bar is equal to 90 minus A. Then simplify. So the value of our A is equal to 74.9 degrees. So that is the value of our A. Now let us solve for angle B. So si angle B lang ato ang kuwang. Since we have the value of the adjacent side of B bar, so we have the value of A and C bar, we can now use the sin tan add rule for solving the B bar. So this is sin or sine B bar equals the adjacent side is A and C bar. So tan and tangent sine B bar. So substitute the value of A. So the value of A is 73 degrees. So tan 73, then tan, the value of C bar is 7.89. 7.89. Then simplify. So B bar is equal to 26.95. So to get the value of B, so this is B bar equals 90 minus B. Then so simplify. So the actual value of B is 63.05. Okay. Now I will discuss on how to find the area of a spherical triangle. So in finding the area of a spherical triangle, we must familiarize the two formulas. These are the excess formula and the area formula. For the formula of the spherical excess in a spherical triangle, so E equals A plus B plus C minus 180. For the area of a spherical triangle, that is pi r squared times e over 180. So let us have an example. So for example, find the area of a spherical triangle whose radius is 6 meters and whose angles are 30, 80, and 100 degrees. So the given are radius was 6 and the angles are 30, 80, and 100 degrees. So always remember the two formulas in finding the area of a spherical triangle. The excess formula, the E equals A plus B plus C minus 180. And then for the area, that is pi r squared times E over 180. So if you're going to look at the problem, the angles are already given, so the 30, 80, and 100. So we can solve for the spherical axis. So E equals, substitute the values of the angles, that is 30 plus 80 plus 100 minus 180. So our spherical axis is equal to 30 degrees. And then now we can solve the area. Since we have the value of our r, which is 6 meters. So just substitute pi r squared. So the value of r is 6 squared times 30 over 180. To simplify this one, we have the value of our area is equal to 6 pi. Okay, so another example. Okay, so the area of an equilateral spherical triangle is 10 pi square meters. Find the measure of each angle if its radius is 10. So we have the given, the area equals 10 pi and the radius is equal to 10. So we are going to look at the problem. Our problem is equilateral spherical triangle. So note that the angles of equilateral spherical triangles are equal. So for example, we have this triangle, a equilateral triangle. So the angles are equal. So now let us solve for the angles. So but before that, let us find the excess. So we can find the excess since the area and the radius is given. So using the formula of the area, which is area equals pi R squared times E over 180. So using this formula, we can find the excess. So just substitute the given area is 10 pi equals pi, the radius is 10 squared times E over 180. So simplify R excess or the value of R P is 18. So since we have the value of R E, we can find now the value or the measure of the angles. So the formula, we have to use the formula of the excess, which is E equals A plus B plus C minus 180. Since our problem is equilateral, then the angles are equal, we can rewrite this one as E equals A plus A plus A minus 180 since they are equal. So just substitute the values. Our E is 18. Then simplify, that is 3A minus 180. Simplify, the value of our A is equal to 66 degrees. So this is the measure of our angle.